or 2 times these calculations, you will become an expert. It's a very simple calculation. That's all. Okay. Again, there is a problem in the sense by using FFE, it can become under-reinforced section. That's the possibilities, but you have to consider all those possibilities. And then you have same equation. I have it. I wrote it up there. Same equation in a different form. They have your moment capacity Mn, nominal moment strength. Mn equals AFFFE times D minus beta 1 CB over 2. Okay. Now, the strength reduction factor will therefore become brittle mode. So you will, in the moment strength equation, you must use a phi factor of 0.55. If you are adjusting your moment to include FFE and not FF, then it becomes a brittle mode of failure, and the phi factor is 0.55 instead of 0.65. Is that clear? Very good, thank you. So there is also another equation. It's just a it's based on test results, and you have development length of bent bars. This is for bent bars. You have it. You have these 3 equations for different FFU values, and these are all in SI units, so you can use them directly. So I mentioned that F prime C is in MPa, LBHF is in millimeter, and so on. So these in SI units, you can plug in the numbers, you can get your development length for bent bars. So if you are designing your shear reinforcement with bends, this is what you will use. Okay? And your FFU is actually based on the actual stress in your shear reinforcement, which is governed by strain of 0.004. So it's quite likely you will use this equation for that. Okay? Yes? No heating also. Thermoset you cannot even heat and bend. Only for thermoplastic you can heat and bend. But you can ask the producer to make a stirrup or shear reinforcement with the bends. They can make it. Once it is made, you cannot bend, you cannot straighten, you cannot do anything. Make sense? Yeah. So of course we have standard hooks in ACI, and also I'm sure it's in IS 456, and so you need to show this extension, which is 12 dB in case of FRP, right? I showed you a small sketch. This is 12 dB, and your development length LDH is from here to here. It's not very clear, I'm sorry, the picture is not so clear, but the development length is from this edge to here. That's what LDH is. And if you have this type of 180-degree hook, then LDH is from this point surface to here, LDH. All right?
What is the use? What is the use of forwarding the length? So if you are taking only that limiting that length, what is the use of forwarding it?
That's a very good question. But yes, that's a good question. Let me think. Mm-hmm. No, what he's saying is, if you are considering this as your LDH, then what's the point of this? But if you have a straight length, let me put it this way, if you are using straight development length, that will be much, much larger than the one with bent profile. So if you use this equation, you will get smaller values. Whereas this is with the bend. So this is development length of bent bars, right? So if you do numbers, this will be smaller value. Whereas if you use straight development length using that embedment equation, embedment length equation, that will be much longer. So that is what it is. That's the difference. Okay. So lap splices, there are, this one I'm not aware of what IS 456 uses. In case of ACI, they have two types of classes, one class A and one class B, and you define your splice, lap splice, based on the amount of reinforcement you provide in that lap. So if your lap splice area of steel provided over area of steel required, so area steel provided over area steel required, depending on your moment strength requirement, your AS required will be what you have here. In most cases, because you are not going to change your bars over the length, the same bar you continue all the way. So almost always you will have a larger area provided than required. So if that ratio is greater than 2, greater than equal to 2, then you classify that based on the splice type. Splice type is classified based on AS provided to AS required. If it is less than 2, it's always classified as class B. So depending on which class, I'm sorry, I didn't have time to check this requirement in IS 456, but if you are familiar with that, please explain to others if that's something you know really well. But in case of ACI, this is what we have, class A and class B. All the bars that are AS provided over AS required less than equal to 2 are classified as class B. So they are saying for FRP, just use class B. For everything, use class B. Class B will have a larger lap length. Okay? So larger lap length is defined as 1.3 LDH. So LDH is given by the other equation, remember, based on FFE. That equation can be used for lap length calculation, but you must use 1.3 factor. So it has to be 30% longer than the development length you have calculated using the equation. You don't have to, right? You can, these days they are having epoxy coated steel binders or even plastic binders. Plastic binders also they use. But actually the whole concept of splice is you don't really have to tie them together. Even if you don't tie them together, even if there is a gap, it should, or at least it is in contact but not tied, that's good enough for splice. That's the whole point. That pull-out strength is based on individual bar. You don't have to tie it. If you weld it, it's great, but that's not going to happen in FRP. Okay. And the development equation, just rearrangement of the same equation for FFE looks like this. That's all. There is no difference. Just exactly same as what we had in that equation for FFE. It's just rearranged, and that's what you get. That's the development length. And for FRP bars, unfortunately, we have to use class B, which is 1.3 times LD. That's what we need to use. This is what will give you the actual development length, and 1.3 is what is required by ACI for detailing. Make sense? Any questions? I think that's my last slide, and we are a few minutes ahead. So if you have any questions, I can answer now. And I also have the examples, 2 examples. Did you get on your emails the 2 examples? You did, but Dr. Das was going to print those examples, so hopefully he'll bring it. And I also have quiz. I love quizzes. Now I think in your teaching also you should try to incorporate that. It makes a lot of difference, because upfront when you are starting the class, you bring them all your students to the same thinking Then you move on, then you build on. It's a very effective tool that I use in my classes also. It's very effective, I know that. Thank you. Anything else? So after the break, I will present either 2 or 3 research projects just for fun. I mean, we all we like to have fun, right? So I'll show you some nice slides, and then tomorrow will be just wrap up and all summaries and stuff like that. I think Dr. Das will give you your certificates also tomorrow. I'm hoping to leave by 10:30 tomorrow because my flight is at 12:30. So hopefully we'll finish up everything by 10:30 tomorrow. Okay, thank you.